Right, question 15, big algebra question, is a part D we'll scroll down to in a minute. So what we've got here, we've got 3x squared, y to the 5, all to the power of 4. So that means we do everything to the power of 4. So we do the 3 to the power of 4, you do x squared to the power of 4, and you do y to the 5 to the power of 4. And when you do things to the power of a power, you times them. So 3 to the 4 goes 3, 9, 27, 81 is the fourth power. X squared to the 4, times them together you get 8. X to the 8, and times these together you get y to the 20. So therefore we've got 81 x to the 8 y to the 20. Expand and simplify. Well, what I would do is I would just multiply these two brackets together to start with. Now a common mistake I saw was timesing the n minus 3 by 4n and then timesing the n plus 5 by 4m. Now if you just imagine what that would be if you just did numbers, you just say you had 3 times 4 times 5. If you do 3 times 4 and then 3 times 5 and then times together, you end up timesing by 3 squared, which is far too much. You've times by it twice. The order doesn't matter in multiplication, so you don't need, like you're doing with when you're multiplying out the brackets, what they're confusing this is doing the 4n times the n and 4n times the minus 3. They're thinking, well, okay, I've got times everything in because there's an add or a minus in between. Okay, but there isn't between these brackets. There's an implied times when there's nothing written. So therefore, you only need to times by it once. So what we're going to do, we're going to do the n minus 3 times by the n plus 5. So we get n squared for the first two things. If you're a bit rusty, first, outer, inner, last. The outer two things plus 5n, the inner two things minus 3n, and the last two things minus 15. We'll simplify that first. That gives me plus 2n minus 15, and then multiply that out. So we get 4n cubed. Multiply these two together, you get 8n squared. Multiply these two together, we get minus 60n. And that's our answer that we're going to write in just here. So just remember, multiply out the two brackets, get something, then multiply it all by that 4n. If you had a third bracket, you just do the same again. You just do multiply out the two brackets, get that, get another bracket here, then do everything times everything. So you'll get 2 things times 3 things, which will give you 6 bits to combine afterwards. Right, let's just scroll down to the last two parts of the question. And we've got 4c squared minus 9d squared. Well, this is a standard one you ought to learn, okay? You've got a number squared minus another number squared. And there's a standard formula for this that people are expected to know. It's called the difference of two squares. You factorize them like this. Because what you'll see is when you multiply this one out, your first two things will give you a squared, your outer two things will give you plus ab, your inner two things will give you minus ab, and your last two things will give you minus b squared. You notice these cancel just to leave you a squared minus b squared. So bearing this in mind, we've got here 2c squared. And we've got here 3d all squared. That's what, if you multiply this out, you get 9d squared. You multiply this out, you get 4c squared. So you've got a number squared minus a number squared. So your a is 2c, your b is 3d, and you can just replace them. So you get 2c minus 3d, and you get 2c plus 3d as your answer. Every time you see an algebraic fraction, factorize. Factorize, factorize, factorize. I see random things like people cancelling the squares and cancelling this x and cancelling that x. You have to have a common factor, top and bottom. That means you must have something times everything on the top, something times everything on the bottom, and then you can cancel those somethings out. Now this one is quite a tricky one. We'll come on to see why. So let's factorize this. We get x minus 3, x minus 4. Here we've got a common factor of x, so we get 4 minus x. Now we got something quite similar top and bottom here, an x minus 4 and a 4 minus x, but they're not quite the same. Right? They need to be exactly the same. We've got a plus x and a minus x, we've got a minus 4 and a plus 4, but if we times one of these things by minus 1, then it becomes the same. If you times by -1 twice, then you don't change anything because the minus times a minus is a plus. So what we're going to do is we're going to times this. We could either times this by -1 and then times that by -1, so you get the times by -1 twice, or you can times this by -1 and this by -1. I think the bottom's a little bit easier for people to handle. So I'm going to do that. I can show you quickly the top as well. So make that a minus. Now make this all opposite signs. So we end up with an x minus 4. There, so the 4 becomes minus, the x becomes plus. And now you're ready to cancel, because you've got the same thing times everything on the top times everything on the bottom. And you're left with x minus 3 over minus x, which is better written as, if we change the sign of everything, we get 3 minus x on the top and we get x on the bottom, and that means we don't have that horrible minus sign. You probably would get credit for that. I'll just check the mark scheme. Does it give credit for that? It doesn't give you full credit for that, and it does say or equivalent. So you actually just say or equivalent, so you would get full credit for this as this, but this just shows off that you're a better mathematician. So do remember, cancel both top and bottom. I'll just show you what it would have looked like if I change the signs on the top. So I'd have written 3 minus x, that changes the sign of that one. So if I change the sign of one other thing, I get 4 minus x, and then I get x and 4 minus x. But remember, you only change the sign twice. If you happen to have 3 factors on the top, you only need to do 2 of them, because 3 of them will give you a minus times a minus times a minus, which will give you a minus, which means you're changing it. You only do it twice. So every time you do it to one thing, just do it to another thing that's times by it, and you'll be fine. Okay? And you can see we get exactly the same answer.